On January 28, 2007, an experienced sailor took his 40-foot yacht out for a short solo trip. He never returned. He vanished near the steep, rocky cliffs of the Farallon Islands off the coast of San Francisco. The weather was clear, but standard search protocols yielded no wreckage and no distress signal. The response from Silicon Valley moved beyond standard search and rescue. Thousands of online volunteers began pooling resources with tech giants to scan high-resolution satellite imagery through a massive network of cloud computers. Why did the tech world stop everything to build a distributed search network for one missing boater? Because the man on that boat was Jim Gray. To understand the effort to find him, we have to look back at the fragility of hardware in the 1970s. This is an IBM System 370, the kind of machine that defined Gray's early career. In a setting like this, system crashes carried high stakes. If a computer failed while processing a wire transfer, data could corrupt midstream. Money could vanish from one account without ever appearing in the other. Gray realized that for a digital economy to exist, databases had to be made trustworthy, even when the machines running them were prone to failure. Back at IBM, Gray formulated the ACID properties, a set of rules designed to ensure that every database transaction remains reliable. The foundation is atomicity. An operation is all or nothing. If a bank transfer starts but the system crashes halfway through, it rolls back. The data returns to its start. Alternatively, if successful, it is written permanently. There is no middle ground. Every modern checkout process relies on this logic. If your payment clears but the inventory system fails to update, atomicity ensures the entire interaction is voided, preventing the kind of ghost transactions that would make digital commerce unmanageable. Gray engineered a way for software to survive its very own physical failures, creating a mechanical definition for digital trust. In 2007, that concept of trust enabled the search for Gray himself. Volunteers used Amazon Mechanical Turk to coordinate the analysis of thousands of separate satellite images. Spreading a massive task across a coordinated network like that was only possible because of Gray's later work at Tandem and Microsoft. He introduced the two-phase commit, a protocol for safely distributing a single database across multiple independent machines. This protocol requires total consensus. Servers send a ready signal to a central point. Only when every node agrees does the system trigger a synchronized commit. If a single server fails to respond, the central point cancels the operation, reverting all nodes to a safe state. This protocol provided the technical assurance needed to scale. Organizations could now treat a cluster of hundreds of smaller servers as a single reliable unit. The search for Gray was essentially a data processing challenge, scanning high-resolution mapping of the physical ocean. By the early 2000s, Gray had realized that database architecture could do more than track commerce. It could catalog the physical universe. He pushed into e-science, building projects like SkyServer to open massive scientific datasets to the public. He wanted to ensure that the data required to map a nebula like this was accessible to everyone, not just a few elite institutions. To find him, the volunteers were utilizing the exact open data, distributed mapping techniques that Gray had spent his final years championing. Despite the scale of the effort, the search was ultimately suspended. 5 years later, Jim Gray was declared dead in absentia. He disappeared at sea, but the architecture he built remains permanent. Every time a credit card is swiped or a flight booked, a network of servers uses his protocols to ensure data is transmitted flawlessly. Jim Gray's engineering continues to silently orchestrate the trust and function of our entire interconnected world.